Okay, for this next problem, what we're going to do is take advantage of Bayes' rule to solve a problem about a condition, the probability of a condition, given an outcome. Okay, and so what we're going to do is imagine that there's a scenario. I'm going to break it down into some smaller parts. Imagine there's a scenario where you have some P strains, okay, with this genotype and this genotype, okay, and you cross them, okay, and so of course you're going to end up with this genotype, okay. But let's suppose in the population there is another allele segregating around, and half the individuals are affected by the influence of this allele. Okay, don't worry if it's dominant. Don't worry about any of that stuff. Just say half the individuals are affected by this allele. Okay, let's just call it D star. Okay, that if you do have this D star allele in you, and half the individuals do, okay, we're not going to worry about these parents. We're just going to think about this one. Okay, then in that case, actually, you have reduced viability of pollen that transmits the little r allele. Okay, so this is 1/2 the transmission rate. Okay, so they're inviable or something like that. There's some sort of genetic interaction that leads to a reduced viability in the pollen. Okay. So what we're going to do is we're going to basically ask this particular question. When there's a probability that an individual is D star is equal to 50% or 1/2. Okay. Now, when we cross this individual, okay, to a tester line, okay, little r, okay, we'll do this, through the pollen. We'll do this to the female germline. Okay. We observe a single round P. Now obviously this can be big R or big R little r. It's not clear. But let's suppose we do have a scenario in which we observe this. And what does this tell us about what the likelihood is that this individual has the D star? Well, we might be, obviously we think there's a 50-50 chance beforehand. But we think, well, there's a 50-50 chance it could have made a wrinkle P, but it didn't make a wrinkle P. So maybe this individual is less inclined because they have the D star allele to transmit that. Now, it's not a big, wouldn't bet the farm on that, but it's an interesting question. So what we're going to ask is in the end, we're going to ask the question is what's the probability that this individual is D star? But to get to that point, we have to ask two other questions. We have to ask what, given that this individual is D star, we want to ask what's the probability, okay, that we would observe a round P bearing plant, given that that individual is D star, okay, and of course we also are going to probably need to know what the probability of observing a round P bearing plant. I'm talking about this one here, given that it's not D star. Okay. Well, given that it's not D star, that's easy, right? It's 50-50. Right, because you either transmit this allele or that allele. So the probability of there being a round bearing plant, given that it's not D star, you either transmit this allele, it's 1/2. Okay, but this is a little bit trickier. Okay, we want to know what's this probability given that it's D star, and what you need to do is you sort of need to mock up a Punnett square. Okay, and what I'm going to do is I'm actually going to basically imagine there's a Punnett square right here. Okay. And usually I show the female on this side, so this is always going to be transmitting a little r allele. This Punnett square is a little bit of a excessive way of representing it, but I want you to think about transmission through both female and male. Okay, so this one is going to transmit either big R or little r. Okay, the question is, if we have reduced viability of this pollen, usually we put 1/2 there, and we can multiply these probabilities out through the Punnett square. But what are the probabilities of transmitting this? Now, you might think off the top of your head, well, it's 1/2, so it's 1/4. But that wouldn't be correct, because if you put 1/4 here, and then you kept 1/2 there, what would the probabilities sum to? Well, they would actually add up to 3/4. So that can't be right, because that would mean that there's some sort of missing class of neither this or that, and it is going to be either this or that. But this has reduced viability of this problem of a pollen if it is a D star. So what you actually have to do is a little bit of algebra, and the way that I usually do that is I say, okay, Well, I'm going to assume that this unknown is going to have a probability of x, okay? And because I said it has half the amount of viability, well, this one would have twice as many, okay? So the probability of transmitting this allele, okay, would be 2x, okay? And then those have to add to 1, because this probability and this probability have to add to 1. So I would say 2x plus x equals 1, okay? And then solving for x, of course, then you would say that x is equal to a third. And then, of course, 2x, which is this probability, is 2/3. So in fact, you can actually put in there probability of 1/3 and probability of 2/3. So that's a little bit of a tricky thing, but you need to think about that. You could do this if this has like 1/10 of viability, because then you would do like x and 10x, and you would solve for x in that case. Okay, so that's is the case. So what you can actually say is like, well, you know, this is going to be guaranteed to be little r, so this is, you know, you could say 1/2. You could fill out the Punnett square completely if you want, but we can just see that this is going to be a probability of 2/3 or 1/3. So the probability around is no longer half. The probability of round is 2/3. Just filling this out, 2/3 times 1/2 is 2/6. Okay, and then this thing is likewise 2/6. This thing now is 1/6, and this thing is 1/6. But these are two ways of getting big R, little r, of course. And two ways of getting little r, little r. So you sum those up. So 4/6, or, you know, as we already said, 2/3 and 1/3 for round and wrinkled. Okay, so to fill that out, then the probability of round given d star is equal to 2/3. Okay, now we're going to ask in one more final problem. We're going to ask, I'm going to erase some of this up on top so you can keep track. We're going to ask, what's the probability that this individual is in fact d star, okay, given that we observe this round p. Okay, now you should immediately, when you hear this, think Bayes' rule. And the reason you should think of Bayes' rule is because we have an outcome, okay, and we're trying to ask something about the condition of this individual here. Specifically, is that individual d star? Okay, so let's actually set that up in the framework of Bayes' rule. We can say, okay, using some of this stuff down here, the probability that the individual, let's just remind you of what Bayes' rule is, probability of A given B, okay, in this case, this would be d star and this would be the outcome, okay, is equal to the probability of B given A times the probability of A all over, okay, the same thing up here, probability of B given A times the probability of A, okay, plus the probability of B given not A times the probability of not A, okay. And you can see that what these are is basically these probabilities of A's is actually the probability that individual is d star or not, okay. You know, probability of A, probability not A. Now this is something called the prior. This is a subtle point that I'd like to make in terms of understanding Bayes' rule. You have some prior expectation for what the chance of an individual being d star or not d star is, which I already told you is 1/2. So that's a prior distribution. So let's fill this thing out. Okay, we're going to say that this up here is equal to the probability of observing a round bearing P. We're just doing one. You can do 2 or 3 as a matter of fact, given that individual is d star, okay, times the probability that an individual is d star, okay, all over, okay, same thing, probability round given an individual is d star times the probability that an individual is d star, okay, plus, okay, the probability of observing round through the alternate way, okay, given the individual is not d star, okay, times the probability that the individual is not d star, okay. So let's fill some of these numbers in, okay, which you've already done the legwork for these, okay. The probability that an individual is round given d star, okay, we already said is 2/3, the probability that the individual is D star is 1/2. Okay. Then the same thing goes down here, 2/3 and 1/2. Okay. Plus, now the probability of round given not D star, we already said is equal to 1/2, and the probability not D star, of course, is equal to 1/2. So you can simplify this, okay? So this would be 2/6 over 2/6 plus 1/4. Okay, so just erase some of this to give you some space. This is going to be all equal to 2/6 right up there over 2/6 plus 1/4. Okay. Now, one thing you can do is you can imagine that it's not just one round P, but it's actually two round P's. Okay. So this in this particular case, so that's individual that may or may not be D stars crossed with the wrinkled bearing P plant, and in fact 2 is. So you could actually imagine what's the chance of actually observing 2 rounds. Well, that would be just 2/3 times 2/3. So I'm going to change this to 2 rounds. Okay. Or 2 rounds and 2 rounds, okay? Well, this would be a round 1 and then a round 1 again, so this would be 2/3 times 2/3 times 1/2, and then same thing down here, 2/3 times 2/3 times 1/2, and then 1/2 times 1/2. So this is the chance of observing a round P and then another round P bearing plant, and then this is the same exact thing, and this is a round P, then another round P, in this case given not D star, in this case given D star. So to simplify that, and I'm showing you this for a reason. You'll see in a moment. This then ends up being equal to 4/18 up on top. This whole thing is equal to 4/18 up on top, 4/18 right here, and then 1/8 down here. Okay, and then I've already calculated this, and so this is equal to. Let me just double check. Yeah. 0.64. Okay, 0.64. Okay. And what I'm showing here is that you used to think it was 0.5, but now that we've had 2 round P bearing plants, it's nudged it up a little bit. Now, if you had more and more and more and more and more of those round P bearing plants, then this probability would get closer and closer to 1, because this number, okay, would become vanishingly small, because it would become very, very, very unlikely that you would observe this relative to that in this particular scenario. So hopefully that helps you understand Bayes' rule.